Okay, problem number 2 on this assignment is the amusement park problem. They gave us a rate, so these are rates, not numbers, but rates of people entering and rates of people leaving. So the basic idea is whenever you integrate a rate, you'll get the total amount of people, right? T was the time after midnight. At time equals 9, there were 0 people in the park. First question says how many people have entered the park by 5 p.m., which is time 17. So you just take that enter equation, this one, and integrate it from 9 to 17. That's all you got to do. And then they actually round it to the nearest people, 6,004 people. If you're grading, 2 points for that. 1 point for getting that work down there, and 1 point for the proper answer. Question 2 says it was $15 before 5 p.m. and then after 5 p.m. it was $11. How much money was collected? So we know that 6,004 people went in before 5 p.m. at $15 a person, so I started with that. And then I integrated from 5 o'clock to 11 p.m., 17 to 23 of that same enter. This was going to tell me how many people went in at that time, and multiplied it by $11. I did make a mistake, however, just so you know. When I first did this on the calculator, I just dumped this in my calculator, I got that number, and I multiplied it by 11. But then my answer was wrong because I didn't round this number first. Right? This was a number of people, so I had to take that number and round it first. I don't remember the number here. Yeah, I didn't write it down. But whatever that number was, if it wasn't rounded, I got too much money, right? So round that number first. It turned out to be $104,000, $104,041. That problem is worth 1 point. Just got it right or wrong, pretty much, on that one. Part C gave us this new function h, which was the integral of e minus L. So this is the rate at which people are going in. This is the rate at which they're leaving. So h, the integral of that is just going to be how many people are in the park, right? How many people have gone in minus how many people have gone out. So in general, h represents the number of people in the park at time t, which we're going to have to answer in just a second. Then they asked me to find h prime of 17. They told me h of 17 was 3725. That's how many people were in the park. H prime, remember the derivative of h is just the derivative of this from 9 to t, which is just this. Right? So the derivative of the integral gets me right back to that. So the derivative is the derivative of this, which is just e minus L. So now you just take e and plug in 17, just dumped it on my calculator. Took L, dumped in 17 on my calculator, and I got negative 380.28. In general, h represents the number of people in the park, and h prime represents the rate of change of the number of people in the park. So that means people are leaving at a rate of 380 people per hour. It's really important when it says to explain the meaning and the context that you have to put in the time. They will mark you wrong if you don't. So it should say the number of people in the park at time equals 17. The rate of change of number of people in the park at time equals 17. You're going to see this over and over and over. It's going to occur in a lot of these practice tests. Got to have that time in there. And the last number of points for that one, was 4 points. 2 for getting to there. So 1 for knowing what the derivative was, 1 for getting the right answer, and then 1 for each one of these. Last question says, when does the model predict the number of people in the park is a maximum? So h is the number of people in the park. So when I hear maximum, a calculus teacher, I think derivative. So the number of people in the park is a maximum whenever the derivative is equal to 0. However, it could be the minimum also. So I just got to make sure it's changing from positive to negative. So what I did was I just took, so the derivative, remember the derivative was e minus L. So if you didn't get this step, this would be a little bit tricky, I think. The derivative is e minus L, so I just put that on my calculator, and I set it equal to 0. You can see it on my calculator. It was going from increasing to decreasing. So that happened at 15.79. Just be careful though, they said at what time, so it's not time equals 15.79. I gotta convert that back to the time of day. So 15 was 3 o'clock, and then that 0.79 gave me about 47 minutes. So it was about 3:47 in the afternoon. So that's it for that problem. Hopefully that made a little bit of sense. Hopefully it helped you a little bit.